Welcome to This Explainer. Today, we're unpacking a topic that is literally the absolute backbone of robust software development: testing. Now, if you've ever felt completely overwhelmed by the sheer volume of frameworks out there, or kind of wondered how the different layers of testing actually fit together in a modern code base, you're in the right place. We are going to map out a super clear, actionable taxonomy today.
Okay, let's dive right into our roadmap for this. We've got 4 sections to cover. First, the landscape. Second, unit and integration testing. Third, essential developer tools. And finally, end-to-end testing.
Section 1. The landscape. Testing tree.
So when you look at a standard testing directory, you usually see this dense web of tools, right? You've got Jest, React Testing Library, mocking APIs, Cypress, Playwright. I mean, on the surface, it's really just a list. But under the hood, it's this beautifully interconnected ecosystem. And to truly use these tools efficiently and, avoid duplicating all your testing efforts, we need to demystify how they actually stack up against one another in a real-world developer environment.
To make sense of this whole taxonomy, it really helps to use a micro to macro mental model. It's a lot like building a pyramid. Down at the foundational base, step 1, we have unit testing. Moving up a layer to step 2 gives us integration testing. And way up at the very peak, step 3, we have end-to-end testing. Setting it up like this just gives us a highly logical way to traverse our codebase and figure out the specific purpose behind every single layer.
Section 2. Unit and integration testing. Testing branches.
All right, let's start with unit testing, down at the micro level. This is the foundational branch of our taxonomy. You aren't testing the whole system here, or even a full UI page for that matter. You're just isolating a single function, component, or utility to ensure that tiny building block behaves perfectly on its own given specific inputs. It's exactly like guaranteeing a single brick is structurally sound before you go and lay down the mortar. Say you have a helper function that formats dates, or maybe a complex math utility calculating a shopping cart total. A unit test verifies that when you pass in specific data, exactly what you expect comes out. It's incredibly fast, super targeted, and it pinpoints exact points of failure.
Right above that in our hierarchy is integration testing. This acts as the intermediate branch. So now that we know our individual blocks work, integration testing basically asks, do they actually play nicely together? We're stepping out of strict isolation here. For example, does your login form component properly pass data to your authentication hook? Or does your shopping cart UI correctly update when an item is added via the global state provider? We're testing the connective tissue of the application. The whole goal here is to ensure the boundaries between your isolated units are functioning exactly as intended when they start sharing data.
As developers, you absolutely need both of these steps in your daily workflow. They're two halves of the same foundational coin. Think about it. You can't trust the combined integration if the isolated microunits are fundamentally broken. But conversely, perfectly coded isolated units are completely useless if they just throw a runtime error the second they finally try to talk to one another. You have to build confidence from the ground up. Ensure the logic works in a vacuum, and then ensure the communication works in a system.
Now, to actually achieve that perfect isolation for our foundational tests, we rely on a really vital standalone technique: mocking APIs. Why is this so necessary? Well, because waiting for a real staging database to wake up or relying on a third-party service that might be having downtime, that just introduces a ton of flakiness into your testing suite. Mocking makes isolated testing possible by basically pretending to be the server. You intercept the network call, return some fake JSON data, and that keeps your tests lightning fast and entirely deterministic. It essentially guarantees that if a test failed, it failed because of a logic error in your code, not because of some random sudden network timeout.
Section 3. Essential developer tools, Jest and React Testing.
When we look at the top foundational tools in our ecosystem, Jest and React Testing Library immediately stand out. And honestly, these aren't just arbitrary add-ons. They are the standard utilities that make unit and integration testing a reality in modern React development. Jest acts as our test runner and assertion library. It's essentially the engine that's executing the code and verifying our expectations. Meanwhile, React Testing Library provides the virtual DOM, which lets us interact with our components exactly like a real user would. Instead of testing underlying implementation details like state variables, React Testing Library forces us to test what the user actually sees and clicks on, and that builds a much higher degree of confidence.
Section 4. End-to-end testing, Cypress and Playwright.
So the really crucial point here is that end-to-end testing is our macro-level branch. This is what completes our testing pyramid.
We aren't looking at isolated functions or mocked data anymore. We are actually automating a virtual user clicking through the entire application from start to finish in a real browser environment running against a real database. Now, it's heavier, it requires a lot more setup, and yeah, it is significantly slower to run. But it provides the absolute highest confidence that your app actually works in production. It catches those nasty, critical regressions that cross the entire stack. And for this heavy lifting, the industry relies on specific, incredibly powerful subtools tailored for the job, namely Cypress and Playwright.
When we map these tools out, a really clean, actionable strategy emerges. On the foundational side, handling our rapid unit and integration tests, we deploy Jest and React Testing library to make sure our core logic and component interactions are completely sound. Then, on the end-to-end side, handling that macro-level user simulation, we leverage Cypress and Playwright to guarantee the full user journey is intact. This totally transforms what initially looks like a chaotic list of frameworks into a highly structured, strategic testing stack. Every single tool has a specific job, and they complement each other perfectly.
As we wrap up this explainer, I want to leave you with a direct question based on this taxonomy. Which layer of testing is missing from your code? We've explored the micro-level units, the intermediate integrations, the bridging power of mocks to keep things deterministic, and of course, the macro-level user flows that mimic reality. So take a close look at your own daily work, look at your own pull requests, and ask yourself honestly where the gaps are. Because understanding this tree and covering all these bases, that's the very first step to shipping truly bulletproof software.